good afternoon. Hello. Hi. All right, ladies, let's do this. We're going to do the lecture in one sitting, so you have workday the rest of the week. It's only about 1 page of notes, so it's not a whole lot of stuff for you today.
How long is it?
It's only took about 30-40 minutes on the other classes, so yeah, as long as we stay focused and get through, we can chop off some time.
My brain cuts in half after that.
All right, let's grab our calculators real quick, and we're going to double check to make sure this thing is set up in the right spot. So please go to home screen first. We're going to go to the settings menu, and we're going to look at the document settings. And under document settings, we need to make sure that that angle says degree.
Wait, I'm sorry. Wait, go again.
Okay. Yep. Let me go ahead and scoot back here. Here you want to go to settings, which is the option, the last one, 5. And then document settings, which I think is option 2. And then you want to make sure that your angle is set in degree. If there's something other than degree there, use either your left or the right arrow to open the little drop-down menu, change it to degree, and then make sure you scroll all the way down until you get to OK to accept it. Okay? And then we're going to go to current document, open this up. We've got a lot of stuff going on here. We're going to be playing with that today. Okay? All right, calculator off to the side. Oh, what happened? Here, what did I do? What did I do? It zoomed it. It did something weird. Hang on, let me fix. Oh, I know what happened. There it is. Okay. All right, so let's go into our notebooks then and start with today's item. Just a quick recap of yesterday. We took these trig functions and just wrote them as decimal points. Basically grabbed the fractions, put them in our calculator, Control-Enter to give us decimal expansions. If you didn't get a chance to finish that yesterday, I will look at it today at the end of class. And then we had this notebook check where we took these special right triangles. We wrote the trig ratios as fractions. They were all sorts of weird, crazy numbers with radicals. You had to reduce those radicals and then drop them in your calculator to give me decimal expansions. This one I definitely want to see either at the end of today or start of tomorrow, depending on where you're at. So I'll just buzz by after class, after lecture, and just check to see where you're at, okay? All right, let's go ahead and start writing for today. We do need a new title and new objectives, even though the code is staying the same. One more time. You do not need a KWL unless you feel you need a KWL. I am no longer going to be checking that you are doing KWLs. They are now at your discretion. Yeah. All right, so our title is still Trigonometry because that is still the main thing that we are working on. But now we're going to look at solving equations with them. Today's the 10th of February. Our what objective is that we will be solving trigonometric equations. So we'll talk about what those are and what those look like. And we're going to be solving these equations by making use of the cross product property. Reminder, what is the cross product property? Yeah, it's cross multiplication. Yep. We're also, because you chose to do the extended version today, we're also going to talk a little bit about the inverse of our trig functions and ratios. I'm abbreviating in my version. You have the long version there to the right. Okay, I'll give you a moment to finish getting the objectives and title down, and then we'll make the screen larger and get to it. All right, I'm going to go ahead and go on. I'll leave mine exposed so that we can see it. And I'll be jumping back and forth between this screen and the other so that we can use the calculator today. All right, so the first item that we need to talk about is what a trigonometric equation even is. So that's going to be our first little bullet point for today. What is a trigonometric equation? Very unimaginatively, it is some sort of equation, so that means an equal sign is in there, ladies and gentlemen. And it's going to have a trig ratio. Bless you. So you're going to see an equal sign, and you're going to see your sine and your cosine and your tangent show up with an equals. We've been writing them, but now we're going to solve them. There's going to be some variable in there that we're trying to get information about. We have all the information we need. Let's start solving equations. The directions for the example says, find the value of x. Excuse me, I need to pull my textbook over because the last time I tried to invent numbers, it didn't end well for anyone on this section. So I need to make sure that I'm not going to invent numbers on you so that this all works the way it's supposed to. So I'm going into the textbook and I'm just going to borrow questions because I can. Alrighty. Let's see here. Alright, we need to find the value of x. Need to find a good one for that. Here we go. Alright, let's draw a triangle. Please make sure it is a right triangle. Let's make this angle 52 degrees. We're going to make this side 13 and this side x. And I will zoom in closer on my work so that you can see it. There it is. And I'm going to switch back to the right-hand side so that I can use the calculator here in a little bit. So let me switch my screens. Oh my goodness. Come on. There it is. Should be popping up now. All right, there we go. All right, so here is our angle. And so that becomes our angle of reference. And what we have to do is figure out which of our 3 trigonometric ratios will be the best help for me in solving this equation. First question to ask yourself, do I have information on the hypotenuse?
No.
No. So which of these functions use hypotenuse?
Sin and cos.
Sine and cosine. So since I don't have information about hypotenuse, they're out. I can't use them. I'm forced to use tangent. So what is the ratio that creates tangent?
Opposite or hypotenuse.
Over hypotenuse?
I mean, adjacent.
Adjacent.
Sorry.
Okay. It's all right. I do the same thing all the time, which I had a second of, what? Okay. So we're going to write out the tangent, but this time it's not theta. We have an actual number for the measure of our angle. It's right here, 52. That's correct. Nice. And then the side opposite 52 is, we're going to write x. And the side adjacent to 52 is 13. It's there. And now we have our equation. We need to solve this for x. I'm going to zoom in a little tighter on the work here. There it is. I need to solve this for x. First off, it's a trigonometric equation. I see a trig ratio, so I'm going to do some trig stuff. I also see fractions. Shoot myself in the head right now. Fractions. I don't want to deal with them. So I'm going to get rid of it. What's happening between the x and the 13? So how do I get rid of division? Multiply. What am I trying to get rid of?
13.
So I'm going to multiply everything by 13. Dun, dun, dun. On the right-hand side, the division by 13 and the multiplication by 13 are going to cancel each other out, leaving me with just the variable, which is my goal. It's by itself. And now, please watch as I write it. You can write afterwards, but I want you to see how it's written and how it's read at the same time. Here we go. This is written as 13 times the tangent of 52 degrees. You don't need the parentheses, and it's all mashed together. It is literally the number 13, the invisible operation symbol of multiplication, and then whatever number is tangent to 52 degrees, because that's one number. Okay? Now we got to go figure out what that number is.
Do you write it down?
Yep, write it down. I don't know what that number is. Thankfully, I have a calculator. Calculator knows what that number is, so I'm going to ask calculator. Calculator, tell me what 13. Now, I don't need to include the multiplication because the calculator understands that if I don't put a multiplication, it's there. And now I need to tell it tan. I'm not going to type. I know there's a keyboard below the numbers. I'm not going to type tan. There's a button right next to the 7 that says trig. Look. Tan. I'm just going to, there, tan. Tangent, unhappy, and then 52. I already set it in degrees, and then I'm going to hit enter, and it's going to spit out a number, and there it is.
Nice.
16 point that. And then, of course, you look at the directions and go, how many decimal places am I supposed to put? I didn't tell you, so I don't know. I'm just going to write all of them that are there and not think about it. Done. Let's do another one? Yeah. Why not? These are actually kind of fun, right? Yeah. And I see some people going, no, these are not fun. You are insane. All right. Let's zoom out a little bit. Let's do this one. Draw another right triangle for me, please, por favor. Make this 61 degrees. Make this side X and put this side, holy cow, I cannot read it because it's dark over there, 24. All right, let's decide which trig function we're going to use. Do I have a hypotenuse?
Yes.
Yes, that means tangent is out. Kick him out. You're between sine and cosine. Look at your reference angle. What side do I have related to it? Opposite or adjacent?
Opposite.
Opposite. Which trig function uses opposite?
Sin.
Sine,
Sine.
not cosine. So this is definitely a sine something. So the sine of 61 degrees equals the side opposite 61 degrees divided by the hypotenuse of my triangle. Our equation is written. We're ready to solve this for x. Again, trigonometric equation, so we're going to do some trig stuff. So you know you're going to use your trig button. And a fraction. We got to get rid of that fraction. This time the variable's in the denominator. I can still use my let's multiply trick. And I still want to multiply by the denominator, but this time my denominator is x. It looks weird, but you can totally do this because x is not 0. Because we were dividing by 0. So I don't know what it is, but it's not 0. What I do to one side, I have to do to the other. So I'm going to multiply the other side by x. Watch what this becomes. X times the sine of 61 degrees equals 24. X is not alone. That's our goal. He smells bad. We need him by himself. I'm kidding. We just want him by himself. Solito, poor thing. How do I get rid of that sine of 61 degrees? What's happening between x and sine of 61 degrees? They're multiplying. So you divide. Since the sine of 61 degrees, all of that thing is just a single number, they're going to cancel each other out. No one cares what that number actually is. My dad has a book that lists all of these numbers to like 8 decimal places. Because when he was in high school and he had to do this, if they didn't have calculators that knew what tangent was, you'd have to go to the book and, yeah. Yeah, I like my calculator. All right, let's go type this into our calculator since we love them so much. Hello, calculator. Here's my hint to you. Use control and divide to make it look like a little fraction. And then you can type in whatever's in your numerator, then the down arrow, and then type whatever's in your denominator, and then hit enter and have it spit out a number. What's that number? 27.404. Okay, let's just round it to, I don't know, 2 decimal places. Pretty cool, huh? Yeah. All right. Let's make this slightly more complicated. It's all right. It's just as easy as this. We're going to introduce one new concept, which y'all are very familiar with, and congratulations, you're on tomorrow's topic. I know, right? Okay, so here's the title of the new topic. We're going to talk about the inverse trigonometric ratios. Now, when you're solving, any old equation, and you have an addition there that you have to get rid of, what do you do? If you've got an addition sitting somewhere in an equation, you want to get rid of it, what do? Subtract. That's its inverse. If you've got a division sitting there, you're going to multiply because that's its inverse. If you have a power sitting there, you're going to square. Let's clean up that word because we've been using a lot of square powers, and so you're automatically saying square root. You want the power and the root to match. So whatever root, you're going to take whatever power. Yeah. or the other way around, whatever power you're going to take, whatever root, as long as they match. I know it sounds weird right now. Algebra 2, you'll do it, and as soon as you see it, you're going to be like, that's what that crazy lady was talking about. I get it now. Okay? It'll make sense then. Trust me. Trig ratios have inverses because trig ratios allow us to calculate sides from angles, like we just did. But they allow us to go in reverse. They allow us to calculate angles from sides. And in order to do that, we have to remove the trig ratio from the angle measure so we can figure out what it is, and that's the inverses. So that is the brand new topic for today, this inverse. I'm going to make it as silly easy for you as possible. Please write down your 3 trigonometric ratios, sine, cosine, and tangent. Note, we don't care about the fraction part of it right now. We just care about the symbols. Each of them have an inverse. I will write the symbol, and then we will write its name, how it's said. Here is the symbol for the inverse ratio for sine. It looks like it's a little -1 exponent. It's not. It means inverse. A little -1 up there is an exponent.
The one on the calculator, and then I was like, am I supposed to pick that one? But
We're about to use that actually. I'll zoom it in a little bit more so it's easier to see. A little better?
can you make it full screen?
Full screen? All right. Better? All right. Cosine also has an inverse. Its symbol looks like this. Very creatively, what can you guess tangent's inverse symbol is going to look like?
I don't know. Just kidding.
Yep, there it is with the little -1 inverse symbol. Very nicely done. Here's how you say these inverses. Ready? The creativity of mathematicians.
Inversing.
Yeah, inverse sine.
Oh my gosh.
I know, right? Wait, once upon a time, way back in the, like, when we were starting this or whatever, a long time ago, they also called it arc sine.
I know.
Arc sine. You can call it arc sine if you want. It's kind of fallen out of fashion. No, not many people use it anymore, but you can totally use it. That's fine.
Say again?
Arc sine.
Okay.
Cosine's inverse is going to be inverse cosine or arc cosine. Again, it's kind of fallen out of fashion. We don't use it much anymore. Tangents is going to be said inverse tangent or arctangent. Now this one hasn't fallen out of fashion. I was still using this in college, and for me that was only like 5 years ago. Okay, so it really honestly wasn't all that long ago. So we used arctangent then too. So it's pretty popular. We still use it now and again. I don't care which one you use in this course. They're all interchangeable for me. Okay, let's do an example. I have some triangle. Name it, please. B,
A.
L, and I heard an A. Blah. I'm sorry. Next time. Triangle, blah. All right, and we want to find the measure of angle. Find the measure of angle A. I don't know. I'm making stuff up. All right, let's make this one 14, and let's make this one 10. All right. We want to find an angle measure, and all we're given are side information that automatically forces us into using trigonometry. We need to figure out which trig ratio we have the information for. Do we have stuff about hypotenuse? Yes, tangent is out. You're down with sine or cosine. Which one is your reference angle? A. And you have information about which side in relation? The opposite.
Cosine.
Sine is indeed the trig ratio, so the sine of angle A is the opposite over the hypotenuse. And we have our equation. Okay. I'm going to zoom it, and I'm going to put the right-hand little bar back so that I can get to my calculator. Okay, guys? Give me a second to switch this out here real quick. There it is. All right. I need to undo this sign because it's in the way. I need A, the measure of angle A, all by itself. To undo the trig ratio of sine, I need to use its inverse. What I do to one side, I have to do to the other. Please know that the way I wrote it on the right-hand side is not exactly correct, but it tells me that I need to take the inverse sign of that side, okay? On the next line, I'll clean it up and write it the way it's supposed to be written, but when I'm doing scratch work like that, I'm just going to drop it off to the side, okay? Inverse sine and sine cancel each other out, leaving me with the measure of angle A equals the arc sine, or inverse sine, of 10 over 14. And now I can go into my calculator and type that mess, and it should spit out for me the correct degree measure. Do that now. What'd you get?
I think it's wrong.
You think it's wrong? Okay, give me your number.
45.58.
45.58?
Yes.
45.58.
I meant for it to be a 5. It looks like a 6 because my pen decided to go bleh. Bleh. That's it. Do you want another example off to the side, or are you pretty happy?
I'm pretty happy.
All right. No general questions? Cool. Thank you very much. The day is yours.